All right, let's dive right in. We're going to tackle one of the most mind-bending concepts out there, infinity. We're going to see why our brains are so bad at dealing with it, and why, when things get weird, the laws of physics are the only referee that matters. So, to kick things off, let's start with a really strange mystery. It involves a puppy, a trash bag, and a hotel with an infinite number of rooms. And trust me, the answer is way stranger than you could possibly imagine. Okay, so picture this, a hotel. But this isn't just any hotel. It has an infinite number of rooms, numbered 1, 2, 3, and on forever. And to make things interesting, on this particular day, every single room is occupied. This is the famous Infinity Hotel, and it's the perfect setting for a paradox that's going to mess with everything you think you know about cause and effect.
So here's what happens. The owner of the puppy, let's say they're in room 14, passes the trash bag to the guest in room 15. Then, the guest in 15 passes it to 16, 16 passes it to 17, and this just keeps going, down the infinite line of rooms. Now, each one of these actions is totally simple, completely harmless, right?
Okay, so the whole chain reaction happens in a flash. The question is, where's the puppy now? I mean, think about it. It's not in room 14, right? That guest passed it on. It's not in room 15 or 100 or even room 1,000,000. For any room number you can possibly name, let's call it n, the guest inside has already passed the bag to room n+1. So, where did it go?
And this is where it gets really, really weird. The answer is nowhere. The puppy isn't in any room in the hotel. It's not anywhere. For any room you pick, the puppy has already moved on. It's as if an infinite sequence of simple, harmless actions has caused it to, poof, just vanish from reality.
And if you try to work backwards to find it, well, good luck. You hit this logical brick wall. You ask the person in room 15, hey, where'd you get the bag? And they say, from room 14. But you ask them where they got it, and you're just sent further back. The search for the puppy never actually begins. You see the problem? You can go on forever, and you'll never find the start. This is what's called an infinite regress. It's the ultimate, it's turtles all the way down problem.
But wait, it gets even weirder. The Infinity Hotel doesn't just make things disappear. It totally messes with our fundamental ideas about probability. It actually breaks the concepts of rare and common. All right, so imagine the hotel management wants to make things up to the guests after, the whole vanishing puppy incident. So they decide to have a book giveaway. You're a guest, and here are the rules. Book A goes to every millionth room, but Book B goes to all 999,999 rooms in between. You'd feel pretty good about your chances of getting Book B, right? The odds seem absolutely overwhelming. But then, right as you're about to open your package, a voice comes over the hotel's PA system. There's been a room reassignment. All the people who got one type of book are now in the odd-numbered rooms, and everyone who got the other book, you're all in the even-numbered rooms. So let's just pause and think about what just happened here. A second ago, you were 99.9999% sure you had Book B. Now, all you know is you're in either an odd or an even room. Your chances are suddenly a coin flip, 50-50. And the crazy part is, the book in your hands didn't change at all. And that is the mind-bending takeaway here. When you're dealing with an infinite set, you can just relabel things to get whatever proportion you want. 1 in 1,000,000 can become 1 in 2 with a simple relabeling. The words rare and common, they literally lose all meaning. Okay, so at this point you might be thinking, all right, this is a fun little brain teaser, but what does it have to do with the real world? Well, it turns out this very paradox hits right at the core of one of the biggest questions in all of cosmology. Why does our universe exist? For ages, scientists have been stumped by this. The laws of our universe seem perfectly, and I mean perfectly, fine-tuned for life to exist. Change one little constant, and poof, we're not here. A really popular explanation for this is called anthropic reasoning. The idea is that there's not just one universe, but a multiverse, an infinite number of them. And we just got lucky. We happen to live in one of the good ones. But do you see the trap here? This sounds exactly like our book lottery, doesn't it? If you have an infinite number of universes, who's to say which ones are rare and which are common? You could just relabel them, just like the hotel rooms, to make universes like ours seem inevitable, or to make them seem impossibly rare. And that's a huge problem. I mean, a real scientific explanation can't just depend on how you decide to label things. If your theory can give you basically any answer you want just by shuffling the names around, then you haven't really explained anything at all. The anthropic argument by itself just doesn't work. So, if pure mathematics can lead us down these rabbit holes of paradox, what pulls us out? What's the final referee when it comes to what's real and what's not? The answer, it turns out, isn't more math. It's physics.
And, we've seen this play out before. Remember Zeno's paradox, the one where the super-fast runner Achilles can never, ever catch a tortoise because he has to cross an infinite number of halfway points? It's a neat mathematical trick, but it's not reality. In the real world, physics takes over, and Achilles just runs past the tortoise. End of story. Physics is the ultimate decider of what can actually happen.
And this points to something incredibly profound. These concepts that we think of as purely abstract, like finite versus infinite, or even simple versus complex, they aren't just defined by math in a vacuum. They are defined by the physical laws of our actual, tangible universe.
And that idea takes us somewhere even deeper. It actually flips our whole understanding of what knowledge is, because it changes how we think about the nature of proof itself.
See, we tend to think of a mathematical proof as this perfect abstract thing that exists outside of the physical world, but it's not. A proof is a physical process. It's something that actually happens. It's a computation running on a physical object, whether that's a computer or your brain. And that whole process is bound by the laws of physics.
What this means is that our confidence in math is actually secondary to our confidence in physics. Think about it. Every single proof you've ever seen, every calculation a computer has ever made, relies on the fundamental assumption that the physical stuff, the paper, the silicon, the neurons, is behaving according to the laws of physics. Our knowledge of math is built on a foundation of physics.
So when you start to see the world this way, with physics as the foundation for everything, something absolutely incredible about our particular universe just jumps out at you.
It's this. The laws of our universe are unbelievably friendly to the creation of knowledge. They're computation-friendly. They're prediction-friendly. They make explanations possible. This is why a physical object, like your brain, can comprehend something as ridiculously vast and distant as a quasar. It's because the underlying laws of reality allow for it.
And that leaves us with the ultimate question, doesn't it? These paradoxes of infinity show us that reality is governed by physics, not by abstract math. But the physics of our reality seems uniquely designed to be understandable, to be explainable. So the final question isn't just what are the laws, it's why. Why do we live in a universe that can be explained at all?